Hi, today we want to calculate the maximum area bound by the curve f of x is equal to x squared and the x-axis within the given boundaries. Now let's very quickly identify the items that we are given in this problem. The first thing we are given, of course, is the function. And the function is f of x equals x squared. The other thing that we are given are the limits or the boundaries. And the boundaries are x is equal to 0 to x is equal to 2. So x is lying between 0 and 2 inclusive. And finally, the third thing that we are given is the reference point, and our reference for this equation is the x-axis. Now let's go to the steps in getting this area. There are two basic steps that we are going to be following in such problems. The first step is to sketch the curve. And the purpose of sketching is to identify the area of interest. I want to call that R, to identify the area of interest. After sketching, we are going to calculate. Of course, we are going to calculate the area, and this calculation is going to be by way of integration. So two basic steps there: sketch to identify the area of interest and calculate by integration. Let's jump very quickly to the first step, which is to sketch. Now, what do we need to sketch a curve? Basic sketching requires that we know the sign on our variable, especially the first variable, x squared. The sign on x squared is positive, so we know that our curve is going to be U-shaped. But again, we know that f of x equals x squared is the same as f of x equals x squared plus 0. So we know that our y-intercept is at 0, or at y equals 0. So let's very quickly go on to sketch this curve. Our curve is going to be U-shaped and passing through the origin. So pretty much going to look like something like that. F of x equals x squared. Now we are given the boundaries of this area as x equals 0, which is basically that point. Then we have x equals 1, then we have x equals 2, and of course that is the upper limit. So our area of interest, therefore, is going to be that area enclosed by the curve, the x-axis, and x equals 2. So I want to call that area R, our area of interest. Having sketched the curve, we can go on to calculate by way of integration the area of that region. The area by integration is given by the definite integral of the given function with respect to x from the lower boundary, which is a, to the upper boundary, which is b. Now in our case, we know the boundaries, so we can go and replace them. Our a, which is the lower boundary, is equal to 0. So a there becomes 0, and our upper boundary becomes 2. So the upper boundary is 2. So we want to integrate this function from x is equal to 0 to x is equal to 2 with respect to x. And one thing you need to always remember is that when integrating, the power increases. So we are going to increase the power by 1. So we add 1 to the power. Then we will divide everything by the new power. So always remember that. Add 1 to the power, divide everything by the new power, and not forgetting our limits, which lie between x is equal to 0 to x is equal to 2. And of course, this is equal to x to the power of 3 on 3 for the same limits. X is equal to 0 to x is equal to 2. We can then go ahead and evaluate. And to evaluate, we are going to take the upper limit first. So x to the power of 3 will be 2 to the power of 3 on 3 minus, if the boundary is 0, then we are going to take 0 to the power of 3 on 3. And of course, 2 to the power of 3 is 8, so that will be 8 over 3 minus the other bit becomes 0. And 8 over 3 minus 0 is 8 over 3, which is equivalent to 2 and 2 over 3. We can therefore go on and conclude that our area of interest is equal to 2 and 2 over 3 units squared. 2 and 2 over 3 units squared. I hope you found this video interesting, and if you did, as always, please subscribe to my channel, share my videos, like the videos, and I'll be glad to meet you again in the next video. Thank you.